Hi class, we are now starting chapter 6. There's a few sections that are going to be divided. For instance, 6.1 is going to be divided into a few different sections to not make the video as long. So let's get started. Okay, so we're going to be looking at chemical equations, chemical reactions. Your chapter is called chemical reactions, but it's also chemical equations. When we represent chemical reactions, we use chemical equations. These are the substances on the left side of the equation are known as the reactants or starting material, and the substances on the right side are the products, what has been produced from the reactants when they combined. There's a physical state for each reactant that is in parentheses in the subscript. We will cover that later. We're going to go step by step on how to understand how to deal with balancing and chemical equations. So scientists use chemical equations to describe chemical changes. For example, the first step in the production of cement is to heat calcium carbonate or limestone to convert it to calcium oxide and carbon dioxide. We represent this change with this chemical equation shown. In this reaction, calcium carbonate is the reactant, sometimes called the reagent or starting material, and the reactants are shown on the left side. So they're on the end of the tail end of the arrow. The products that form in the reaction are calcium oxide and carbon dioxide, and they are shown on the right side of the arrow where the arrowhead is facing. So chemical equations also convey the ratio of reactants and products. For example, when hydrogen and oxygen gas combine, they can react explosively to form water. In this reaction, every 2 molecules of hydrogen gas react with 1 molecule of oxygen gas to produce 2 molecules of water. Notice that this reaction follows the law of conservation of mass. Atoms are not created or destroyed in the chemical change, and the total mass of the products. So what you start with is what you end with. They just, in a sense, if you can see here, they change partners. So we describe the reaction of hydrogen and oxygen using the chemical equation. So we have 2 hydrogen molecules plus 1 molecule of oxygen, because remember, these are diatomic. They are found with 2 attached, and they produce 2 molecules of water. The subscripts show the number of atoms. So this is telling you there's 2 hydrogens here, there's 2 oxygens here, there's 2 hydrogens here attached to 1 oxygen. The subscripts show the number of atoms within each molecule or formula unit. The numbers that precede the chemical equations are called coefficients. So these numbers that are in front, there's not a 1 here. So if it's blank, that's defaulted as 1. And then there's a 2. So anything that's more than 1 will have a coefficient in front of it. The numbers, those are coefficients. These numbers show the ratio in which these compounds react or form. The coefficients are written to show the smallest whole number ratio in which molecules react. If a reactant or product does not have a coefficient, we assume that coefficient to be 1. So chemical equations describe what happens at the atomic level, but they also provide a ratio for larger reactions. This equation tells us that 2 molecules of hydrogen react with 1 molecule of, 1 molecule of oxygen to produce 2 molecules of water. What if 2 million molecules of hydrogen reacted with 1 million molecules of oxygen? Based on the ratio in this equation, 2 million molecules of water would form. If we have correctly described the ratios of reactants and products in a chemical reaction, the equation is balanced. In a balanced equation, the number and type of each atom are the same in the reactants and in the products. A properly balanced equation shows the smallest whole number ratio of reactants to products. We're going to expand on this in the next section. But to give you an idea, if it's a balanced equation, we have 2 molecules of hydrogen, 1 molecule of oxygen, and that produces 2 molecules of water. So what that means is nothing's ever lost or gained. You can't create something out of nothing. So here we have 4 atoms of hydrogen, 2 and 2. We have 1 molecule of water, that oxygen, that consists of 2 oxygen atoms. And on the other side, with water, we still have 4 atoms, and we have 2 oxygen molecules.